why are humans producing code at all? It's not because, there's no other reason other than the fact that like we always talk about taste. Like taste is like the word in vogue, and taste is irrational. It's an opinion. You can't teach a robot taste because it's my taste and I wanted things to be a certain way. And the bottleneck is actually like, can I convey my taste to you and kind of serialize it into a prompt? Yeah. The answer is probably not. I think most people can't.
Hey Daksh, thanks a lot for joining me.
Thanks for having me.
Maybe we can start off by telling us about what Greptile does.
Yeah. So at Greptile, we're building AI that reviews pull requests with full context of the code base, and it surfaces bugs and enforces best practices for software companies.
Awesome. And what brought you to building this? What was the journey? Like, what's your background?
So I was in school before this. This was 2 years ago, and I met my co-founders there. We moved out of San Francisco after college, and we were really obsessed with teaching GPT-4, which was a new model at the time, how to understand a very large code base. For context, this is like the first model that's actually good at programming, but it has a 4,000 token context window. So you can barely fit more than a couple of files in there. And we got really interested in, can we take this large code base and allow these models to reason over them? And what is now called RAG, and at the time was GPT Index was what the library was called, which for, I'm assuming legal reasons, was renamed to Llama Index. We built an early version of that, but highly targeted for code bases. And from there, we just kind of iterated and tried to figure out, okay, well, what can you do if you were to teach an LLM how to understand a code base? And we built a chatbot, we built an API. And then over time, just spending a lot of time with customers, we realized the most interesting thing we could do with this was catch bugs in pull requests. Turns out that context really helps when you're detecting bugs. The hardest bugs actually require you to look at many, many files in a code base and not just the thing that's changed.
Cool. And then I guess it's interesting because you're still building a code context platform independent, like of the form factor that you're releasing. Like, how do you think about that? Is it like, have you switched from one motion to the other, or now you're just like, this is an outcropping of the larger technical product you built?
It definitely started out as an outcropping. It started out as, hey, this is going to be one of the many applications we built that uses code-based context. And then the more time we spent inside of the world of code review and code validation, the more we realized this is actually a very interesting opportunity, because code review on its own is not very hard to replace because it's not very useful. When people that work at software companies will tell you that code review at software companies is very much like security theater. You're not really catching things, rubber stamping. It's almost like a cesspool for political activity inside of your software org. And so therefore, just getting AI to diligently look at code and find issues in it is already a pretty big step up from what is typical human code review. But it turns out actually that code review is part of a bigger apparatus of things that we do at software companies that are really just catching bugs and enforcing best practices. And you're doing tests and you're doing QA and everything. And these are things humans don't like doing. And they're also things we're not really good at. I often think about human code review as like the perfectly unoptimal task for the human brain, because you're asking it to take a very complex system, which is a code base, and you're asking a pattern-seeking brain to find anti-patterns in it. It's just not a thing we're good at. But we can actually teach models to be very good at this. And we can give them the tools that they need. For example, we can give them the tools to run the code and maybe generate tests against the code, maybe deploy the code to a browser and click around. And we can actually completely automate the process of validating code, something we don't want to do, humans don't want to do, and something we're not good at. So it just doesn't really make any sense that there would be human intervention of any kind.
Yeah, that's really interesting. I mean, because there's this first pass of like, humans are bad at code review. Like, we already knew humans are bad at code review because of social problems. And, there's a lot of blog posts about best practices that sort of get you through that, which I think is really, and so there's like naively, you're like, okay, like AI would be better. But then the second pass is kind of more interesting because it's almost like the ways in which AlphaGo plays Go that are not intuitive. There's an insight that perhaps the failure modes for code review are correlative across humans, right? And so suddenly, like, I don't know, I guess it's a very bitter lesson thing where you're like put enough data into it and it like figures out on the other end.
Yeah, and I think what's interesting is one school of thought when you're, so I guess, very broadly, our mission is to build AI agents that autonomously validate code changes. And the sort of misplaced way to look at this would be to build a testing bot and a QA bot. You build a bot that generates unit tests and a bot that generates integration tests and a bot that does QA testing. It's almost like building faster horses. Yeah. When in practice, an interesting question is like, why do we do all this stuff inside of a software org anyway? Like, why are we doing unit tests and why are we doing integration tests? Why are we doing QA? And when you think about it, actually, well, you do unit tests because they're easier to write and faster to run than integration tests. And integration tests you do because there's so many states in modern software. There's this combinatorial explosion of potential paths. And so you can't cover all of them in an end-to-end test suite. And because your end-to-end tests are incomplete, you do QA, maybe hire a QA firm, maybe you do bug bashes. And every piece of this seems to exist because something else doesn't work right and is incomplete. And then the next question is, well, why don't we just have 10,000 perfect end-to-end tests that cover every path? And the reason is that no one wants to write them and they require a lot of energy. Well, more specifically, they require a lot of intelligence. And the assumption that all our software practices were built around is that intelligence is scarce. And that was always true and then suddenly just stopped being true. That's like the most foundational change that's happened in the last 5 years. Intelligence became abundant and nearly free. And now it sounds like we actually can write complete end-to-end tests. And then the question is, well, do you need it to generate and maintain end-to-end test suites? Well, not really, because the only time that code can break is when something changes. And so you actually want to detect things breaking when they're changing. And so you actually don't need a continuous test suite. You just need exactly the right tests generated at exactly the right time when the code changes are made. You run only those, and then you just tell people to fix the stuff instead of waiting till something is in staging or production to detect an issue.
That all really resonates. How do you think about that in terms of building a business? Because it seems, I think the same thing, we can get into the differences in code generation in a bit, but like the same thing is true on the code generation side, where the workflow that's going to gain adoption is the one most proximate to the current workflow, but it's not the right workflow, right? Like, I feel like that's like the kind of through line what you're saying. Like people want code review because they're used to doing code review, but you don't want to be the person, putting up your hand in the market and be like, I know you want code review, but you're wrong. You actually just want your code to be right. So like, we're going to fix that for you. And so like, how do you balance giving them what they're looking for with what they need?
So I think the natural state for any test suite is degradation over time. The building a better test suite and writing new tests is something that happens when things go wrong. And so if you just create really good code review bots and then soon they start running the code in the background, the API for the user is the same. You still see comments in your pull request. It's just that the comments happen to come not from AI looking at code, but actually running code off in a sandbox somewhere and then coming back with results and finding you the exact line of code that broke things. And you'll start using it. It'll start getting more powerful. And then over time, people will stop maintaining the test because things will stop going wrong. Yeah. And then over time, you realize, well, why do we have a QA firm? It seems like they haven't caught anything in months. Maybe you don't need a QA firm. And even if that doesn't happen, there'll be a new generation of companies. We're an 8-person company. We're pretty process light as we have to be. And odds are that if we get this product right, we'll actually just never do QA. And it might be that we never write tests. Yeah. Like we write tests today, but it's very possible that, that our testing apparatus never needs to get more sophisticated because we would have just replaced the entire paradigm with something entirely new.
Yeah, that makes sense. You do. It's like the answer is really that it's just like being good at UX. Do actually do what they need, but make it feel like what they've articulated as wanting in terms of like how it fits into their current workflow.
You also, to some degree, want to sort of understate the disruption, where if we were to sell this product as, we're going to replace your testing in QA, you're like, well, I don't believe you. Yeah. It was like, wait, we'll replace your code review. And then that's all we were going to promise. And you'll see what it does when you have it. And then you have it, and then it starts doing all these very interesting things. And it turns out that actually, like sneakily disrupting something is like a less violent and more effective thing to do than to disrupt something in your face.
Are people more willing to accept that level of disruption given what they've seen on the code generation side and like having been surprised and like now not just that they've gone from like it'll never work to oh wow it works, but now it's interesting because it's like it also just plays directly into the tie between these two because you're like now it worked, now I have way more code to review, so maybe I'm more credulous that code correctness as a service is plausible.
Yeah, I think it's a combination of those things. So when I kind of look at our own adoption curve, our growth rates are very similar to code gen growth rates in 2023. And it seems like we have roughly an 18-month phase difference between the adoption curve for code gen and the adoption curve for for code review tools? And the answer is actually quite simple: is you started producing 10 times more code, and most teams would say that they're reviewing pull requests about as fast as they can, and people aren't really exactly happy with how quickly they're doing it. And so the moment you start producing 10 times more code, now your code reviews are certainly not scaling. There are probably hundreds of open pull requests. And so the thing you're trying to do is actually just make the pull requests get merged faster. You're not even thinking very far beyond that thing of like, okay, should this catch a lot of bugs, and maybe now it's starting to eat into my testing and into my QA workflows. You just want it to review pull requests faster, so you don't have 1,000 open pull requests. Because at some point, you can't get the value of code gen if you aren't merging things. And so you're creating all this value that's just sort of being heat lost if you're not actually reviewing and merging things as fast as you're producing them.
Yeah. And then I guess a question I'm interested in, and I know you have like very specific views on, is like, why is code generation and then verification or correctness why are they durably different problems? I have a base intuition that seems like there's a lot of momentum broadly towards problems with LLMs being solved by adversarial LLMs, but like beyond that, take me through how you think about the shape of how those two interrelate.
Yeah, I think there's actually two questions within this. So it is, why is this a separate product? And then why is it a separate company? And so with a separate product, we have sort of a specific view on how software should get produced. Or will get produced. So an interesting thought experiment is, what is currently standing between us and having a perfect AI software engineer that turns tickets into pull requests? And a common answer might be, we're some steps of intelligence away. And I think that's sort of mistaken, because our Jira tickets aren't that good. And more specifically, what that means is that while the models are getting smarter every year and capable of handling more complex tasks, we're not getting any better at describing in an articulate way upfront exactly what we want out of a ticket. Yeah. There's opinion and taste that is not serializable, or at least we're not good at serializing it. And when you're building in a world where everything's changing, you try to cling on to what's constant, which is human intelligence is not getting better year on year, in any meaningful way at least. And so it follows that we're going to be producing software in sort of a variety of ways, where there will be some tickets that are highly specifiable, and those will be produced entirely by Devin, because there's no reason there should be human intervention, assuming that they're perfectly smart AI software engineers that exist in the future, which seems totally reasonable that they would. And then there'll be a large collection of tickets and tasks where, because we can't describe what we want, we're going to be operating in sort of an iterative inner loop. And if we're operating in an iterative inner loop, then we're using something that is similar to a modern day IDE, which is your Claude Code or Cursor or something of that kind. That space of products will likely be fragmented, because if you're going to work this tightly with a product, the ergonomics matter a lot. And we have a very opinionated, discerning set of customers, which are developers, and they care a lot about the specifics of the tools that they're using. And so what will actually end up happening is you'll have tons and tons of different ways of producing code within the same company. And if we're going to produce code in all these different ways, we're probably going to continue to need a Git-like version control system. I think something in the shape of GitHub or GitLab will persist. And we're going to open something along the lines of pull requests too. And you're going to need a central validation layer that, no matter how that code is produced, tells you if the code is correct or not. And this validation layer needs to be sort of in the team sphere. So the pull request is, in some sense, the farthest left it can be. And it needs to validate code no matter where it came from. So there's a simple answer why it should be a separate product. It exists. The user is different. Our customer is not a developer. It's a team of developers. And the second aspect is, well, why should it be a separate vendor, which is an interesting question. There's a couple of things. So a lot of these code gen companies do have code review products. And it seems like their first attempts weren't nearly as good as the prevailing code review companies, the ones that purely focus on code review, like ourselves and some of our competitors. And the question is, well, why is that? Well, it turns out that code gen is a sufficiently different problem from code review, to a point that code gen companies don't have a lot of transferable skills that can be applied to code review. They're just so different that we have to deal with a very different set of time and resource constraints. We can take 15 minutes to review a PR. Yeah. It can be very compute intensive, because per developer, your code review agent runs like twice a week. That's how many times you open a pull request. You might ask Claude Code to produce code for you 20 times a day. So the amount of time we have to update the index, the amount of time that we have to query the index, the amount of time that the agent has to run is just way more than any of the IDEs have. And that actually makes it just a very fundamentally different problem to solve. So it follows that if this is a very technically difficult and different problem, because actually customers do care about us catching one more bug. So it's a discerning customer. They care about this technically difficult problem being solved correctly. It follows that the customer the company that wins this sort of is focused exclusively on this thing. It's their first priority. And then the second thing is actually even more interesting, which is it appears that according to customers, there's an intrinsic value in the discriminator being different from the generator. And what that means is if I am producing code with all these vendors, I would like a completely independent vendor telling me if the code is right, because I want the failures and outages to be completely uncorrelated. Yeah. It's why your company has a finance department and yet pays an auditing firm. And it's why you have a different security vendor than a cloud vendor, because you want these outages to be uncorrelated. You want complete neutrality in your validation.
Do you think that, so like, that makes a lot of sense. In the limit case, the loop closes temporarily, right? And then the limit is like just in time, both things happen, right? And I think you make a good argument that doesn't mean that just one thing happens. It just means that both things happen faster. And so do you think that as you increasingly remove humans from the loop, which has got to be something you want to do because that makes your product better, and make it go faster in review, that again, something that makes your product better, it's still like, does it get blurry?
I think to some degree it does, because of course, at some point, if you're a code gen provider, it's your value can now it can be measured with how validated your code is that you're producing.
Yeah.
I think that
you're their bottleneck.
That's right. So and yet like it just seems to be the fact that there are going to be many vendors that produce code, and you can't have multiple different ways of validating code at your company. You need a central layer that your team collaborates on the best practices. It learns your practices on a team level.
Yeah, you have a bunch of programmers in one linter.
Yeah, exactly.
Yeah.
One thing I like to think about too is everyone has the test suite on their computers. And yet you don't rely on individual agency for your code to be thoroughly tested. You spend millions of dollars on CI runners. And you do that because actually there is value in running the tests all at once for everyone and being able to enforce the practice across the entire company instead of relying on individual agency.
Okay. Yeah, that's really interesting. All right. Switching gears to what I told you we were going to talk about in the first place.
This was fun.
All right. So I think that like part of the durability between the two categories is like, well, what's hard about understanding code? And then I think there's two buckets, like what's hard about understanding code and what's hard about code review specifically. So let's like start with the former. What are the hard problems in actually getting an LLM based system to truly understand what's going on in a code base?
Yeah, so it actually isn't even intuitive that to do good code reviews that you would need deep code-based context. It's not, at least not a conclusion we would have easily arrived at. We had just incidentally spent a year and a half as a code-based context company before we started doing this. And so the thing that's hard about code-based context is the red herring of trying to treat a code base like a book where every page is a file. The canonical way to do RAG, or if you can call it canonical for how long it's been around, in this, I guess, in the AI timeframe, it's been around forever. But the canonical way to do it is you create a vector embedding of each document, and then you do a semantic similarity search with some type of embedding model, and you choose the things that are most similar to the query. Now, there's a few problems that cause this to break down. Most, at least sort of like documentation, for example, the paragraphs actually do have self-contained meaning in a way that most code files don't. They really only contain meaning when placed in context of their surroundings. Code bases are not like books. They're graphs, and these graphs represent logical systems. And what else is true is that embedding models are very highly optimized around natural language, and code just doesn't work very well with, which is kind of interesting because for large language models, they're also trained primarily on natural language, and yet that ability translates very nicely to code, and actually do perhaps perform better on code than they do in natural language. But for embedding models, this is not true. So one example of this is any two Python files are usually more semantically similar to each other than a Python file and a TypeScript file that do the exact same thing. They're not really capturing semantic meaning. They're a little too syntactically oriented. And so the one thing that we had to do really early on was translate all the code to English and extract its semantic meaning. Incidentally, this was actually very expensive at the time, but it turns out that incremental improvements in intelligence didn't really matter for this specific task of translating code. And so then the costs eventually went to zero because dollars per IQ are trending down every year. So we translate the code to English, we embed the meaning of the code. We also parse the syntax tree, we parse the functions, the classes, we understand how they're connected. And this matters a lot because when you're doing a code review, you kind of have to think, okay, well, to review a particular function change, what is it that I need to take into context from the code base? And we consider this the blast radius of the diff. The blast radius of the diff consists of every function call that is within this changed code, every place where this code is called. And you probably want to do that recursively to figure out what the full trace is or the potential trace is. And then you probably also want to look at imports. And you want to look at semantically similar code. So if you're running, executing SQL, for example, in a particular function, you probably want to look at other functions across the code base where you're also executing SQL to figure out, okay, what are the patterns around how we do this? Do we care about SQL validation in this code base? To make sure the positive patterns are being propagated through the code base.
Yeah. Which is like, the shape of this problem is there's like a halting issue going here, like possibly, right? Like,
yeah. So we have kind of a naive solution to the halting problem, which is we let the agent decide when to not keep going, and then we rely on the fact that the model companies are aware of sufficiently many multi-domain halting problems that their reinforcement learning, their post-training is sort of pushing them away from being trapped in these problems, which hopefully is true. We're offloading. We like to offload all the tasks that we can to the models. We can focus on the things the models are not going to get better at. So in the code base context thing is also interesting because different languages operate differently. There's like object-oriented languages versus functional languages have different looking graphs. It matters in some languages what the imports are, in others it doesn't matter that much. There's external libraries and dependencies, and do you pull those into context? Does it really matter? Can you assume that the requests package in Python is actually just fine? Wherever the issue came from, it's not because of the requests package. You can treat that as a black box.
Was it intuitive to you that going to natural language wouldn't be too lossy?
So it actually depends on what you're trying to do. We maintain both records, both the actual code and its natural language translation. But to the extent that we're trying to figure out what the code does to evaluate it against, evaluate any changes against what the code is supposed to do, we actually do have to extract the meaning. And the way we think about this earlier is, okay, it was actually very naive. We were looking at an embedding model and saying, well, the embedding model is not capturing meaning from this code. It's probably because we need more intelligence to capture meaning from code. We should use an LLM. That's the most intelligent thing we have at our disposal. And so we use that to translate the code, and it just worked better. At the time, we definitely were not thinking of it in a very sophisticated way. Yeah. And looking back now, you can, pseudocode is in some sense not lossy. Mm-hmm. To catch bugs in supporting context, you do need access to into the underlying code. We actually just use the natural language index as a lookup table. So the way you find the code is you use this natural language index, but then the thing you actually include in LLM context when you're reviewing the code is the code. Yeah.
How do you, it's interesting to hear that you like having fluency on, I feel like there's a lot of people who reach for large language models because they do very specific functional things. Whereas it sounds like in a lot of your architecture, you're like, well, where do we, like the question of like, where do we need intelligence is an interesting one. And has that always been something that's like you've talked about internally in terms of like how you think about where to apply LLMs?
I think until recently, it's how we thought about it. So before the Claude 4 family of models came out, I think the almost always correct way to build an LLM app was to build a flowchart, which is you have some set of tasks that you want to accomplish, and then you have, okay, so at the time, this is what our code review would have looked like. We would have said, okay, you have the diff. The first step is you use our code-based context algorithm to find the relevant parts of the code base. And there's some LLM magic involved in finding the correct code-based context too. But that's essentially a module. You find the context, then you produce an initial set of comments, and then you use another LLM and its own set of sort of semantic filters that are learned over time to figure out what is a very high severity issue that has been detected versus what's a nitpick. And you label those, and then you surface what matters. So this is something of a rough outline of what a flow chart would look like. And the thing that changed with the Claude 4 family of models, the first set of models are really good at using tools. And that actually shifts the paradigm quite a lot, because actually the flow chart is a process. It's almost like if you had someone who was moderately intelligent, the way you would have them be very effective at their jobs is you'd build a lot of process, and those are guardrails, and they eliminate both the bottom end and the top end of their potential outcomes. And they're really sort of optimized around downside prevention. But if you had a very intelligent system, then what you do is actually give it very highly specialized tools and let it figure out when and how to use them. And when you're doing code validation, there are certain aspects which require downside prevention. And there are many other aspects. You're actually capturing the upper end of the upside, which is catching those sort of tail end bugs, actually is extremely valuable. And that paradigm of how to build agents has become sort of a very important part of how we think about architecture, which is not only do we let the LLM do the tasks, we also figure out, we let it decide what to do. We just build really, really good tools. And actually it changes the system of what you do as an LLM app builder quite meaningfully. Because if you're building sort of application layer AI companies, then it's possible that your job is shifted from building scaffolding for LLMs to building very good tools for LLMs that are very highly specialized for the specific tasks you're doing.
Yeah, I remember that being my takeaway from just the MCP craze. You're just kind of like, like there's like all the rigging everyone's been doing to get things in a format for the LLM is probably ultimately going to prove useless, because the right answer is just let it figure out what to do.
Yeah, I think with some exception, there are paradigms, and this includes parts of code validation where the downside prevention matters. Like it matters that we consistently capture certain types of bugs, because teams will come to rely on us successfully catching certain things. For example, if you notice that Greptile is really good at detecting race conditions, you might start to not pay too much attention to them yourself. And now it really is important that we catch all the race conditions. And so we then now need some process, some flowchart for the downside prevention. But I think that there is this, by my best estimates, we're capturing maybe like a fifth of all the bugs that exist in a pull request, and humans were maybe capturing like a 20th, and we're doing a fifth. And what that tells me is like, well, actually, there's a lot of sort of uncaptured value that no one is catching these bugs. They're just going to sit in production for days or weeks, months, and they will surface themselves, and it'll be like a hellish on call for someone at some point. And like preventing that is, I think, a very technically difficult problem. And there are times when capturing more of the upside at the cost of increasing the variance actually is worth it. But I think that the question you should ask when you're building LLM tools is it better that I am capturing the top 10% of outcomes, or is it better that I'm avoiding the bottom 10% of outcomes? And that should determine the amount of agency that you give to the LLM. Yeah,
that makes sense. I guess my sentiment was just more that, but we're on a continuum now where like you're just going to see more agency over time.
Yeah, there'll be time in a lot of tasks that will become the.
At any given generation, you should be evaluating very specifically where that threshold is. But like your prevailing assumption should be that the threshold is towards everything. All right, so you've kind of teased it in a few of these answers, but like going from code context, like what's specifically hard about code review?
There's a lot of things, but I think the one that was very unintuitive to us is it's very difficult to figure out what's a nitpick and what's a severe issue. And our instinct around this at first was actually just to start listing all of the different things that are nitpicks. So actually, context on why this matters. If you have 20 comments in a pull request, the available attention on each of them is approximately 0. If you have 4 comments in a pull request and 2 of them are very valuable, that is actually a very good ratio. You probably will pay attention.
But that almost sounds like part of what's hard about code review is that it's been done so poorly for so long. And so your data set for what it looks like is corrupted, right?
Ignore the data set in many ways. Because I think so few bugs get caught that matching existing human code reviews is not a value add thing.
But they're in the underlying LLM. Like it knows, it like wants to do the nits.
Oh, we also don't tell the LLM that it's reviewing the pull request. So we give it this abstract task so it's untethered from how this has been done in the past. We just say there's code and your job is to detect issues in it. We obviously, our system prompt is like thousands of tokens, but like that's roughly the.
All right, sorry, I interrupted. Keep going. You're saying that like the hard part is at first is like figuring out.
Actually detecting like what is severe and what's not. And what's interesting is like our initial attempt was to just start putting tons and tons of examples of nitpicks into context and see what happens. And with enough hammering, we actually were able to get it down to just be a few comments. And there were people that said, "Hey, it stopped detecting this thing that I care about." And it's like, well, why do you care about this? No one else cares about this. And it turns out that the hard part wasn't the fact that LLMs are unopinionated about the severity of an issue. It's the fact that there is no universally adopted definition of a nitpick. Everyone has a different idea of what a nitpick is. And the next obvious instinct then is, okay, well, if everyone has a different standard of what a nitpick is, then we actually just need a slider of some type. But then it turns out that not only do people have a quantitatively different idea of what a nitpick is, they actually just have a qualitatively different idea. People have, like, there are things that team A considers to be a nitpick that team B doesn't, that team B considers to be a nitpick that team A doesn't. And so you kind of have to learn from each team what their definition of a nitpick is. And people's best practices are there's a high variance in how well documented they are at different companies. A lot of the times they really are just absorbed through people leaving comments in each other's pull requests, early on in their time at a company. What you consider to be a nitpick is certainly not documented. It was never a problem. You just kind of dislike the person that leaves a lot of nitpicks, but you never write down why the thing that they said was a nitpick. And so there's no data set, there's no understanding. Because the thing we do is actually just like learn what a nitpick is from you. So Greptile will look at the first and the last commit of any pull request. And what the difference between the first and the last commit tells you is what did they change based on Greptile's comments. And when we look at that diff, we can also tell, okay, these comments were addressed in the code and these comments were ignored. And they start to see patterns in what comments were ignored. So it'll automatically start to synthesize a filter and say, okay, they seem to always ignore any comments that are around using type hints in Python. It sounds like they don't really care about that. So I'm just going to stop commenting on that. And so it'll create these decaying filters because, of course, like team standards change over time. The company's standards at like year 1 of their existence probably different from year 3. So it creates these decaying filters, which will block out the nitpick. So in the first week, it might feel like, wow, it's leaving a lot of comments. In week 2, it's like, wow, these are very high signal. Like there are a few very high quality comments in all of my pull requests. And every team, it just like learns the filter on its own. And it's a surprisingly tricky thing to build and was like oddly, I want to use the word high bit, but that felt on the nose. It was like the most important part of like, it was disproportionately impactful on how much people liked the product in a way that we couldn't have anticipated.
Was there a moment where you weren't sure it was tractable?
It at first didn't feel like that should be the important thing. I think the important thing should be that we catch a lot of bugs. But the complaint that we heard over and over again was there's too many comments and they're noisy. And it's interesting because it's actually hard to figure out how well Greptile is doing on catching bugs because you aren't catching them either. So the fact that it's catching any bugs is a step in the right direction. So that also means that like creating evals is kind of difficult because creating a data set of evals data set that contains like real world bugs is actually a very non-trivial problem. So one of the ways in which we do this is we'll find post knowledge cutoff open source pull requests which are labeled like patch or fix. And then we get blamed to find the original source of the pull request that created the bug in the first place. And so now we have a data set of bugs that people cared about enough to fix later on. And then seeing if Greptile can detect those, because those went undetected every single time in code reviews. Because if we actually were to go and find a data set of bugs found in pull requests, incredibly tiny and not a very good data set. Like all we did was cache the things humans are already caching. It's not a very valuable product. So to cache things that humans categorically missed. And I think that data set is like non-trivial to create.
And then, but how do you balance between, because it's like a lot of that is accounting for the sentiment of your customers when you have this larger goal of just making their code work and not have any bugs in it. And like, how do you like, and given the types of systems you're architecting, pulling in one direction is always this tension because it could take away from some other aspect of it, of it doing well, right? Given that it's non-deterministic. So like, how do you approach it?
I think just to some degree, there's like a social engineering aspect to solving bugs, which is, yes, in theory, if you're working with a highly rational, very high attention to detail, emotionless human being, then you would give them all of the problems with their code and they'd fix all of them. But in practice, that is not who you're working with. And if you give someone everything that's wrong with their code, they're going to ignore you entirely. And so if the eventual impact is to create very high quality code, you actually want to give the human only some important things. And an interesting question then is like, well, we're doing a Devon produced PR, which we actually probably can give it like all 60 things wrong with this pull request, and it will diligently solve them. And that's a pretty interesting direction to potentially go and detect if the code was written by an AI or if the stuff at the end will be fixed by an AI. What I suspect is that the human solving the bugs or having to read the pull request comments in the first place is sort of a temporary thing also. I think there are a very large percentage of the bugs that Greptile detects don't require opinion on how to solve them. They just are like, there's a almost objectively correct way to fix that bug. And so one school of thought is maybe we should be labeling certain comments and saying this one AI should just fix. These ones a human should look at. And then now you've reduced the space quite meaningfully and you can accomplish both the goal of giving a human only a little bit of work to do and also actually fixing everything that's wrong with the pull request.
Yeah, because the sentiment converges. Like people, like yes, like the nitpicks doesn't matter. Kind of like you might as well fix them. But when you find real bugs, that serves both goals every single time because people are going to be like, oh wow, thank you.
Yeah, and to some degree, like it probably doesn't really. I mean, a lot of those nitpicks are things like it really doesn't matter. Like the type hints, for example, are a good best practice because they help prevent future bugs. Yeah. But it's insane. Like when I think it's like everything that your apparatus needs to do is it needs to catch bugs and prevent future bugs. Yeah. And prevent future bugs is just like, in other words, it needs to enforce best practices, which is the set of processes you've like created to prevent a future bug.
Yeah, and then there's this whole weird rabbit hole because a lot of what's being enforced in code reviews isn't about code quality; it's about code legibility for humans later.
Yeah, and whether code legibility will matter in an AI world, I think is like an open question. Like, well, to some degree, yes. Well, if humans are involved at all, then legibility will matter a little bit.
But they can use tools like like code context engines, right? Like for it to be more legible.
The question is like, like what is the minimum, or like what is the lowest level of abstraction at which you will need to operate on code? Yeah. And my theory is because like. We you take a computer science degree from like the late 2010s versus like a computer science degree from like the 80s and 90s operating at very different abstraction levels. You can go through an entire degree whether like really ever
so this corollary is like what is object code.
Exactly. So it's like, would you need to know this stuff? And you'll touch on it a little bit, but in practice you might never need to like look at anything below the high level programming language that you use. But then I think the one difference here that people seem to be overlooking is that the compilers for high-level languages are deterministic. And in English to code compiler, at least so far as we've described them, they're neural networks. They're not deterministic. And that does mean that if we make them sufficiently complex, the errors propagate. And if you have a prompt that's slightly off, you might actually end up with code that's slightly off, and it layers over time and really amplifies the mistakes. And from that perspective, the legibility maybe matters because there will be times. They'll be rare, most likely. Hopefully they'll be rare, but there'll be times you might actually need to look at the actual code under the hood and figure out what's going wrong with it. I think it's plausible that would need to happen. Yeah.
That's interesting. Because so many things, I didn't really thought about it. So many things are not correct. And they're not just like stylistic linting things. They're just like how the thing is factored.
They're structured in ways that make sense and is maintainable.
Like, is it dry, right? Is like
There's also so one thing I often think about is a question we get often from customers that are sort of checking Greptile out is it better or worse at certain languages? Mm-hmm. And because we abstract the language by translating it to English, the answer is generally no. It performs equally well in every programming language. The exception is actually Terraform, and any infrastructure as code. It's very bad at that. Yeah. And there's a couple of reasons. I think one, even if you had sort of Terraform is a little different because Terraform applies like sort of. To understand what's going to happen, you actually have to know what the existing state is. Yeah. And but then even just sort of CDK, which is sort of AWS's equivalent of infrastructure as code, and that one does contain all the information. It's not really a CloudFormation apply. It is like all the definitions of the resources that you want to spin up. Question is, why doesn't that work as well? And it's interesting then to see, okay, well, what are LLMs actually doing when they're figuring out if there's a bug in a piece of code? What they're doing is they're trying to predict what would happen if you ran the code. And to predict what would happen if you ran the code, what you're effectively doing is you're approximating the interpreter. Yeah. If you're figuring out what's going wrong with a piece of Python code, you're doing is approximating the interpreter function. Mm-hmm. And the interpreter function for any infrastructure as cloud type code is actually very complicated. There's a lot of moving parts, and there's a lot of information that isn't encoded. The interpreter function of Python is very self-contained, which is not the case for something like the system that turns AWS CDK into real AWS resources is like far less tractable. Mm-hmm. And I think that's sort of interesting because that means there's always this large variation in how these things will perform based on the tractability of the function that they're approximating. And it has sort of this second order effect of, well, we might actually either need to provide all this additional context to LLMs and hope that they do get good enough at approximating, or it might be that actually the more efficient thing to do is actually have humans involved and like DevOps to some degree. And anytime there's like a single human involved, it throws a wrench in the whole system, and the whole thing needs to be just like significantly more resilient. Like often, an interesting thought experiment is like, how much easier would the Waymo problem be if the roads were only Waymos? Probably way easier. Like even a single human car on the roads make the Waymo problem like significantly harder. Yeah. And I think the same thing is true for like coding agents and code reviewers. Like having a single human involved at any place, whether or not they need to be there is a separate question. But if they're involved at all, it makes the entire thing more complicated.
That's interesting. Well, but I guess the other thing that comes to mind though, in the difference between code and Terraform is, but the shape of both problems is reasoning about edge cases when you don't know external state that the code is operating on. And I think most code is using a data store that like you can kind of reason about, right? Like at least like in practice, like a programmer working today, like can like think through the edge cases of what might come out of their Postgres database. Whereas like, the AWS API is like noise.
Yeah.
And so like a human has no idea, like how that converges necessarily, like unless they're like steeped in it. And so that's kind of there's like an interesting aspect to that, like where I don't really know what that means or like why LLMs would be better at like predicting. There's probably just there's more examples of like what people do when they think through edge cases for standard coding data stores.
Yeah, it's an interesting point too. I also wonder, the other shift at this point we're starting to get like really close to the model where I'm sort of maybe less equipped to have good opinions on, but like like with reinforcement learning working, you probably can make these things better at like understanding code, but just giving them a sandbox, having them generate the code, run it, see what happens, just keep doing that on a loop, and then they probably would get better at detecting bugs that way. And I wonder if an interesting question could be, and again, this is probably a good question for someone who has a lot more experience in DevOps and how the cloud works, but just doing the same thing, just giving it like some way to capture the full state of a cloud deployment, and then giving it a ton of Terraform applies and see here's what happens when you run Terraform applies, and just learn what happens. And there are probably patterns. I mean, the reason that you can sort of reliably determine what would happen if you ran Python code is because even though there are variables you don't know about, you don't know the processor that's going to run, you don't know how much memory you have, you can make some generally safe assumptions. Most computers are kind of the same now, and the Python code is going to run on a computer with a Python interpreter. And you can generally say, okay, the P99 is the same. And I wonder if you can probably do that with like a lot of systems. And there are systems where actually the P99 is not the same, especially if there is state. And therefore, your prediction of what would happen if you ran the thing is not contained within the thing.
Yeah. Well, we've designed around data stores we can reason about so that we can write the code that interacts with them. Whereas like that's kind of true of infrastructure, but it's more important that it's more like how it runs is perhaps more important than like us being able to make sense of it. I don't know. It's kind of a vague.
Yeah, it's also an interesting question. Another interesting one is like, should we be actually changing the type of code we write so that more of it is self-contained, and just reduce the complexity and like the reliance on external systems.
Yeah,
like,
where all the functional people write. Like,
maybe. And there are other things you can do. Like one of our customers migrated their entire very large code base into a single monorepo. It's still microservices architecture, and but the monorepo is actually a great idea because that means all these coding agents, because they have access to this repo, can find the relevant context around, and they can reason about how the microservices might be connected. And they're so forward thinking. They're thinking about a future where it can understand how the APIs talk to each other from the docs, and then figure out how microservices would interact with each other. And so what would happen if you change something in microservice A? This is like the type of thing they can't even do that yet, but like they're preparing for a world where they will be able to. I think it's very interesting.
Well, it's kind of a broader question of like, should we re-architect systems in a way that the LLMs are well suited for, or should we just like figure out how to apply them to the current messy real world?
I think the question is like different, and therefore the answer is different depending on who you are. If I was a consumer of AI developer tools, I would work on re-architecting the way I do things to get them closer to what LLMs are good at and what they're likely to get better at. If I was creating AI coding systems, I would optimize them around what everyone is doing. Like I think of like, how is it that biped robots are like the way we're thinking about house robots? That's not the optimal thing. I mean, like we figured out what the ideal shape for a dishwashing robot is, and it's a box with like it's like a dishwasher. That's a dishwashing robot. Like it wasn't a biped that stands and does dishes over your sink. And a general purpose robot, the ideal version is a biped because we actually designed an entire world around bipeds, and like we built everything around bipeds because that is like the primary consumer of all things we've ever produced. And to some degree, like we can either wait for the LLMs to get good at our messy systems. We can't try to meet them in the middle. And the good thing is the incentives are aligned to meet in the middle. Like as a software engineering leader, I'm incentivized to try to get closer to what LLMs are good at, so you can extract more value out of them. As an LLM provider or like an application layer LLM company, my incentive is to get closer to where the engineering teams are today, and build for them.
Yeah, I mean, it becomes a timing thing. Like, and I think the bipedal robot is a very good example, because it's like, from an engineering perspective, doing purpose specific things for all the functions is shorter, seems quicker, right, than getting something general to work. But if something general is work, like as you mentioned, the world's pretty set up for bipedal things with hands, right? Like, and so if that was ready sooner, why go through all the bother of the fan out of specificity?
Well, the question being that, is there a ceiling? Like, are there things that we're fundamentally limiting the robots from doing because we're locking them into a biped type system? Or are there like things we're specifically limiting? Are there things AI agents could do if we just re-architected our system in a certain way? And I will never get to them because the way we've structured our systems aren't that good. And it seems the latter seems sort of not plausible to me. Like it seems, I'm generally in the camp that LLMs will get extraordinarily good at everything, and anything that is an intelligence problem is like on its way to be solved. And I think I don't know if that's a correct bet, but it is. The way I put this is like, if my company or product only works if LLMs never get good at a certain thing, I'll be very worried. I would just assume that they're going to get really good at everything, and so the only limiting factors will be human irrationality. When I think is like, why are humans producing code at all? It's not because, it's no other reason other than the fact that like we always talk about taste. Like taste is like the word in vogue, and taste is irrational. It's an opinion. You can't teach a robot taste because it's my taste and I wanted things to be a certain way. And the bottleneck is actually like, can I convey my taste to you and kind of serialize it into a prompt? The answer is probably not. I think most people can't. When I think of like Rick Rubin, like what is his value is like, what is his value proposition? And it is that he is incredibly potent at serializing his taste. Like he has really strong taste and is very good at turning it into a series of tokens. And like I think everyone else other than him is like not good at that, and will need to work with LLMs.
It's like until you go through the singularity, a highly levered human is still better. Right, like the leverage on us that are actually good at these things at some fundamental level is still like more interesting than, although like I don't know, it gets very blurry because it's like there's an aspect where it's even if Rick Rubin is better, maybe that you don't need Rick Rubin level. For all of music, like all the music that's created, right? Like empirically, that's not true, right? There's other popular music that is probably of some, objectively lower quality. And then the other thing is like, there's also just this weird timing thing of like humans' appetite for change and like appetite to like back to the robot thing. Like, am I really gonna like? The other direction is like I go remodel my entire kitchen, right? Like it's like I'm gonna have to get rid of the physical, the physical, like you move the physical world around in a way that just makes a lot more sense for an automated version, and then there's this weird like, should it be backwards compatible at the margins? Like, does that help me even if only psychologically? I don't know.
Yeah, I feel like economics determines a lot of these outcomes after a point. I was thinking about like, I think it's at some point when I was growing up, we got a kitchen exhaust over the stove, which is a thing that like Indian houses didn't used to have for the longest time. But it's kind of interesting because like actually in Indian cooking is the perfect place to apply like a gas hood, because there's a lot of high heat and a lot of like aromatic ingredients, and we just never had those. He's like, well, you probably could wait until they figured out how to make kitchens or stoves or like cooking utensils some capacity, like make in some direction, make them so that you didn't have to add a bunch of stuff to your kitchen for it to work well. But it turns out that at some point you draw the line and say, okay, the economics actually are in a direction where enough people are willing to remodel their kitchens to accommodate like a hood on top of their stove to exhaust all of the gases, that you have no choice but to do it. It's just not economically viable to serve you anymore. And I think a similar thing will probably happen here. At some point, I think of like Perforce as an example. Like right now, if you're on Perforce, you just don't have access to any of the good AI developer tooling. Now is probably the perfect time to, like, if you were holding on to Perforce for a long time, now is the time to not use Perforce anymore. Even Bitbucket to some degree, which doesn't have as many good tools as GitHub or GitLab do. Now would be the time to like switch off of that. There's enough reason, like the robots are not going to meet you there. It's very likely that like it'll never be economically viable to build tools for you. And you should focus on trying to move over to GitHub so you can access all this stuff.
Well, because software, it can rip through the system a lot quicker in software, and as durable as like enterprise procurement might be, it could suddenly become existential in terms of risk to not adopt. So you're like, yes, it doesn't matter anymore that I have a sensibility about our legacy relationship with Perforce.
Yeah, it's plausible that until now, there weren't strong enough currents for people to switch from Perforce. Well, a lot of people probably did, but like the fact that there are enterprises that are on Perforce on Subversion, it's plausible that like until now there just wasn't enough downside to sticking with it. But now there is. Like there's almost guaranteed enough downside. Like there are software teams that, I mean, like the velocity of a software team today is fundamentally different from this velocity of a software team from 5 years ago. It is almost unrecognizable if they really have adopted these tools to their fullest degree. And I think that it's one of the we never when teams reach out to us or like express interest in us and they don't already use AI to generate code, we actually just don't work with them, and we don't feel bad about not working with them either. Because if software is really their core competency and they haven't adopted AI tools, then I actually don't think they'll be around long enough. Like that's actually like a negative on our revenue retention. And I would much rather work with like companies that have truly adopted these. Like we think of like companies that we work with as in some odd way, like as investments. Like we care a lot about companies that are growing really fast because obviously they're going to spend more money with us over time, but also they're the type of companies that we want directing our roadmap. And they're more indicative of what the software company of the future looks like versus like legacy ones. There was this, I think, and I might be misquoting here. I've heard this like, and it's passed down through a chain of people, but about Stripe refusing to serve any companies that were made before the year 2000. There's like, if you're really interested, we'll serve you, but like we're not going to go after you. And like I think a lot of AI companies, especially ones serving engineering teams, should probably think along those lines too. It's like if you're kind of a legacy company, I think it might actually not be worth our time to serve you. And there are many old companies that are very forward thinking. You work with like giant 30, 40-year companies, been around forever, extremely forward with how they think about with AI. And it's just quite inspiring to see actually like a company of that size being this fast moving with their adoption of these tools. But I think if there are plenty of companies that are like only 10 or 15 years old that are very far behind, and we're just not particularly interested in working with them.
Yeah. That's awesome. be the kind of company that Greptile wants to service.
Yeah, it's just some indications. Like if we're very small, but like if you think of like one of the large like AI agent companies that have done really, really well. Like if Cursor refuses to work with you because you're too slow, I think you should really look inward. And you should think about like why, like what is it about my organization that is preventing me from like adopting these frontier tools?
Yeah. Sweet. Okay. This has been really, really fascinating. Thank you. What should we look forward to from Greptile?
So many things. We're launching so many things. We're gonna run your code. That's like a big part of, I don't know when this comes out, but we might already be running your code by the time. Well, not your code in particular. We'll ask first, but like if you're using Greptile, we'll be running your code as part of checking it, which is exciting.
Awesome. Well, thanks a lot. I really, really appreciate the time.
Thank you. Yeah.